Okay. Good evening, everybody. So now almost we have reached. This is our 17th week. So, so not 17 weeks, session 17 because last 14 days we had missed our timelines. No part apart. So today we will have some short recap. So maybe you can recall. I have just given the points so that you can recall what are the concepts we are going to study. And then we will look into the hypothesis testing part. Okay, so it's better if you refer our textbook. I will also share one more resource after the session, which is good resource for the reading that you can have look. And today we will look at what is hypothesis testing, some initial terminology which we need before going into the hypothesis testing, and we will see some tests which we can do hypothesis testing. Okay. Okay. So this is somewhat a recap. Is it visible or shall I zoom in?
Yes, visible.
Okay. So now this is the recap part. So the first I have said that after data collection and guessing the distribution, next part. Okay. So what we can do with we have collected the data and we have guessed the distribution of the population. Like suppose it is continuous data, like we have measured the height of the students or the children, then you can have guessed that it will be a what type distribution, which distribution it will be if I measure the heights. Okay, let's start. Remember, recall the distributions, which distributions you are remembering, names of the distribution, probability distributions,
Binomial, Poisson,
binomial, Poisson, then
normal. Normal distribution.
normal distribution, then
Uniform distribution.
uniform distribution. Yes, this is what the first distribution you will learn basically is the uniform distribution. So there is coin toss and other examples which you have seen in any general statistics course. Okay, then uniform continuous we have one seen. So within this, if I measure the heights of the students, what can I guess about the distribution of the population? Can I guess it is binomial? Can I guess it is Poisson?
No,
Will it
no.
be uniform or will it be normal?
I think uniform or
Uniform. Why
normal.
uniform?
Normal, yeah, normal, normal.
Normal means what?
Means it is for continuous random variable.
Yes. So normal distribution is applicable for the most of the continuous wherever you are doing the measurement, like the height you are measuring, temperature you are measuring, or the length you are measuring. Wherever you are doing the measurements, there you can safely assume, not in the all cases, but most of the cases, that it is the uh, just to wait. Okay. Hello, welcome, sir. So safely when we are doing the measurement, so that is the continuous uh, random variable, we can safely assume that it is going to be the continuous random variable will follow the normal distribution for the population. Okay.
हाँ जी, yes.
When we can say that it is uniform, in which cases? What do I mean by my population follows the normal distribution? Sorry, uniform
Uh,
distribution.
Uniform, when the number is very, means population is very large.
Not population is very large. What I am saying that it is uniform means observing the probability of observing any value in the population is same, right? If I take what is my observation, suppose there are 100 people, I am going to randomly select a person. So probability of selecting any person is same. It is 1 by n.
100.
1 by n.
Yes, yes.
So it is 1 by n. So suppose there are n people in my group, for each n people. So my first person, what is the probability that I will select the first person? It is 1 divided by n. What is my second person I will select? It is 1 divided by n. So for my ith person, it is going to be 1 divided by n. Okay. So this is what my uniform. So whenever I am doing the experiments where each outcome is equally likely, so possibility of happening the each outcome in my sample space is equal, then I can say that it is a uniform. Okay. What about the binomial? When can I say that it is binomial?
When means two possible outcomes are there,
Yes.
and events also should be independent.
Yes. So we have seen extensively that binomial distribution, like you rightly said, there are only two types of value it will take, 0 or 1, yes or no, male or female. So it is the uh, binary variable, first of all. Okay. So my sample space is only two values for my sample space. And if I am measuring that, suppose I did 25 times measurements, how many times I will get the success? So that is one. This is my, in this case, I can say that, oh, it is going to be my binomial variable. Where we can do that? Suppose I'm doing the test for the, suppose I'm doing test for our anemia in our Dhan case. Okay. So I'm doing testing a girl whether she is anemic or not. So this random variable can take only two values, whether anemic or not anemic. So I am saying that if I randomly select the 100 girls, what is the probability that 25 girls will be anemic? So in this case, my random variable is going to be the binomial probability distribution it will follow. What about the Poisson? When I can model my data as a Poisson,
When events are rare, and the rate of happening those events is also constant.
yes. So there are some rare events which are happening. So mainly we can say about the frequency. When there is something frequency is there, we can model it as a Poisson distribution. Suppose you take the visitor to bus station or bus to the bus station. The frequency of bus, you are studying in FWS 1, the frequency of bus to the village. Okay. In that case, you can model it as a Poisson distribution where for the first time you can on an average select the frequency. Okay. Once you select the frequency, you calculated the frequency by some experiment, you can model it as a Poisson distribution. Okay.
But yeah, bus will come daily only. So it's how it is a rare event.
See, no, bus is no. I'm not saying that rarely is you see bus. No need to be rarely only. Like it is art per definition. Yes, you are right that it is. selected as a rare events, but rare not in case which we are using like once in a while, like corona, rare event. It is not like that, but not frequently, often, everywhere. Like that, in that sense, you need to take it. So basically, even if you take that frequency, when it is frequency is there, you can assume that you can follow the Poisson distribution. For that, what you need to do, just you need to change it to the frequency. Like I simply observe one day, it is not going to enough. I want to observe every hour or every 2 hours or half a day. Okay. And then I can convert it to the our Poisson distribution. I can fit those values in that and I can model it. Okay, so don't take this rare word seriously. Yes, theoretically, as per definition, the word is there, but you can focus morely on the frequency part. Okay, wherever there is frequency, you can observe that part. You can model as a Poisson distribution. Okay, okay. So
Okay, okay.
these are the only four distributions because we are on very basic course of statistics. We are just, you can say that we are just getting introduced to the statistics. Once you go digger and deeper, you will know that there are plenty or number of distributions are available. There is a log normal distribution, there is a geometrical distribution which we have not seen. So it is also a interesting one, the geometrical distribution. So like that, there are n number of distributions available which have already modeled. And in some cases, some in your some experiments, none of this distribution will help you. Any of the distribution if you take, it will not fit to your data. In that case, you need to derive your own distribution. So that is some advanced part, that how you can build your own distribution. We are not going to do that. Those who are interested can do study about it, that how to build your own distribution. Normally, you need not to do that at 99% whenever you are doing the study. Only 1% of study which is very complex experiments which involve so many parameters. In that case only you will need that. Okay. Then what is the central limit theorem? We need to just fast forward it. What is the central limit theorem? In simple words, I don't want the theoretical definition. In simple words, what is the central limit theorem? Maybe Priya or Vijay can share about it. Anyone can share, but because they were there in that session.
No, way I don't remember.
Okay. Anyone? Sajal, Sarvana?
Yeah, means if the sample size gets large, then the sample distribution tends to be normal distribution.
Okay. So you were 99% correct. There is one
Sorry,
word
means
just
the mean of
yes.
yeah, mean of our
So
sampling
sample mean
distribution can be approximated as normal distribution
yes.
by the
So
normal distribution.
yes, correct. So minimum we are taking as a 30. So above the 30, if you take your sample size is more than 30. So that means from village you are selecting more than 30 people as a experiment and then you are doing your study. If you take the some samples like that, more and more samples, if you take another 30 samples, okay, so that means your one sample consists of 30 people. Again you have taken same 30 samples, so total 900 people. If you calculate the mean of each sample, so you have collected data of first 30 people and the mean age or the average age is around 25. Then you have taken another 30 people, the average you have calculated, the average it is around 26. Like that you will get some 30 values. And if you plot those values, these values will, the distribution of these values is going to be normal distribution. Whatever distribution this mean your population may have. Suppose your population is uniform, correct? Whenever you are doing the random sampling, you are going to the village, your population distribution is uniform, correct? But when you collect the data, you draw the samples from that data, and if you check the mean of the each sample, the distribution of that sample mean is going to be normally distributed. Okay, this is what our
Central limit theorem.
central limit theorem says. Then we have seen that we have just introduced the point estimation. You can just leave it apart. But we have seen the interval estimation, right? For interval estimation, we have seen the margin of error, right? So how we can do the interval estimation? What is the interval estimation?
It is a range of values.
Range of value, but for what? This is range, correct? Interval means there is some interval is there. You have fixed that interval from 10 to 15. But for what?
Like if you tell means for age calculation in India,
Okay.
uh, we have to calculate the estimation like interval estimation means some range will be there. Not average age 15 to 25 like this.
Yes, correct. So you are almost there. You are right, absolutely right. You are given example. Now I will tell you the simply what is there. See, you are doing some experiment, and it is your population. So you were saying about the India. So India has average age. If you collect all, you go to each and every person on the same day with some supernatural power you have. You same day you collect, or within a year, if you collect every person's age as of today, and if you take the average, then you will get one value, right? So you will get
Yes.
one value which is population mean, average age of India, right? That is something. Suppose that value is 34 for today. Suppose, okay. In practical, whenever you are going for the study, you are not going to study each and every person in the India. So what you are going to do? You are going to select some few persons from India. Just a minute. बाळा वाजवू नको ना ग ते. Please. Yes. So normally what you are going to do, you are going to select some randomly few people, and then you are going to calculate the average age. So that is our mu x bar. What is our x bar? This is our sample. Sorry, this is
Sample mean.
yes. So for this is our sample mean. Okay. So this is the real mean, which is just to change the color. Okay, let it be. So this is the our real mean. This is what our sample mean. So this might not be the exactly same. So here you might get 28. Reality it is 34. You might get 28. Okay, because you are going to select only few hundreds of people, and actually there are crores of the people. So now based on this, you are going to estimate that what is the mean of the India. Okay. So what you will do with your statistical methods, you will select one interval. So with this, our margin of error, which is our Z gamma, you will calculate this, and you will plus and minus it into the your sample mean plus minus our MOE, which is margin of error. And this interval is going to be, suppose you take interval as a,
Mayur,
our margin error is
are you
10.
writing in the right side?
Oh, okay, okay, sorry. So we'll just zoom out. Okay. So somewhat there, I will just change it to here somewhere. Just give. Next time I will keep one slide blank for our review. Okay. So what will happen? We will calculate this margin of error. We will simply set that Z gamma. Okay. And what we will do, the sample mean, here I will write it as a mu x bar, which is 28. Suppose we have calculated. Then what we will do, 28 plus minus Z gamma, or it is margin of error. Don't worry about the word, this symbols and etc. So suppose our margin of error is 10, we have calculated it. So our range will become 18 to 38. This is our interval. Okay. So with 95% of confidence, we have calculated the margin of error, which is 10. So what does that this range means? With 95% of confidence interval, we have calculated this range. It does mean that suppose you take another sample. So now this is our mu x bar 1. Okay. If I take another mu x bar, okay, and it is, I said it is x bar 2, mu x bar 2. And if I calculate the sample, again I have taken the sample size of 1000 people randomly over the India. And if I calculate, it is now it is going to be somewhere around uh, 34, 32. Suppose it has calculated to the 32. Okay. So what will happen? The real mean, okay, the real mean will reside out of this 20 times. If you repeat this process 19 times, your mean is going to reside in this range. Okay. If you do the 19 times this sampling process, and if you calculate the intervals, the 19 times your population mean getting captured in this interval. Got my point?
हाँ जी.
So for that, I have shared the visualization link. Last time even I did this visualization. What is this interval estimation? For that, you can just go and check that link. Animatedly, you will come to know that what is the procedure. Okay. Yes. So then we have calculated the margin of error. Correct? Last time, if you remember, in the Excel, we have did this exercise that we have taken our confidence interval as a 95. Our alpha will become, so confidence interval is my 95%. So my alpha will become 0.05, right? My standard deviation is 5. Suppose I know the standard deviation. So this method involves, I know already the standard deviation and my sample size is 100. Yes. In that case, I will calculate my margin of error, which was 0.98, and my confidence interval will become, so because my average was 70 last time, so it will become 70 plus 0.98 and 70 minus 0.98, which is this. Okay. And this is what we have did using the Excel. So I will show you the Excel part also. So last time which formulas we have used. Okay. So now we have spent so much time on the recap, but let it be. So now we will see about the hypothesis testing. Okay. So what is exactly the hypothesis testing? This is I have taken from the I think Wikipedia. So in the standard words, the statistical hypothesis test is a method of statistical inference. So we are going to talk something about the our inference. We are going to infer something about the population or our something. We hypothesis means we have something in our mind. Correct. Hypothesis testing means we have something in our mind. We assume that something uh, about the data before we know the data. Like suppose I might say that the average age of India is 34. This is my assumption, right? Because I have not checked any data, I have not gone in the our survey part or anything else. Okay, but with my intuition, I am saying that the average age of India is 34. So statistical hypothesis test is typically involve the following process: the calculation of test statistics, and once you calculate the test statistics, then a decision has been made. Okay, either by comparing the test statistics to critical value. What is the critical value? There will be some parameter. Suppose it is z, then we will decide some critical value, because how we will decide it based on our confidence interval, whether we want 95% confidence or we want the 99% or we want some 90% confidence. Based on that we will decide the this critical value, or we can have the p value. So p value is nothing but conversion in the scale of 0 to 1. So this is our probability, right? So based on this probability we will decide that whether we are going to accept the hypothesis or reject the hypothesis. And this is very interesting. There are 100 specialized statistical tests have been defined. Those are available. So in general, in normal, you will see this test. The first one is that t test. Then there is f test, z test, and there is one more interesting is chi-square test. So in general, we will, as we proceed into our course, we will see these types of the statistical tests. Okay. Okay. So now we will just look into the steps involved in the hypothesis testing. So these are the steps. What you will do when you are doing. So I hope you are clear about the what is hypothesis testing. So basically, before going into the village, you are having some assumptions. So while many of you have might have done it in your study plan, that before you go into the FWS1 or DPS, you are doing some design of your research. In that, you are having some estimates or some hypothesis. Like my hypothesis is that the average number of people dying in a block is only 10 people. Okay, or I might say that uh, the average rate of milk in the Tamil Nadu or some Madurai district is 18 rupees. Okay, and then you will collect some data, and then you will try to validate that whatever my hypothesis was it right or wrong. Okay, so this is what is called as a hypothesis testing. So we will formulate the hypothesis. So there are generally you will formulate two hypotheses. First one is the null hypothesis, and the second one is the alternate hypothesis. So main thing which you want to remember, the hypothesis will be related to the population parameter. Okay. So what is population parameter? Population parameter can be the mean or the standard deviation, or we can have the others, like variance. These are the parameters of the population, right? So we are going to formulate our hypothesis in connection to these three, okay, or any other parameter if you have. So what is so demo? My mainly we will deal about the mean or average. So my null hypothesis, which is also called as H0, my null hypothesis is that the average age of Madurai district is 18 years. So this can be my null hypothesis. Okay. What is my alternate hypothesis? Alternate hypothesis we call H1, alternate hypothesis. So I put alternate hypothesis, you can have that the I will write shortly, I will write that the age bar or average age is not equal to 18 years. Okay, so I can have this. So this formulates. I will first do this hypothesis formulation. Okay, so this is the first part. What is the second part? The second part is that the suitable significance level. What is the suitable significance levels? Uh, up to what accuracy I want the my hypothesis tests to be happen, right? So maybe up to 90% I'm confident, or 95% I'm confident, or some 99% of confidence. On standard in our social sector, even on the research academia, people are using 95% of confidence. Okay, where you are not so serious, or you don't want much accuracy, or you are lacking in the resources, you don't have a human resource, if you don't have time, if you don't have money, in that case some people might select the 90% of accuracy level, which is sufficient. But in some critical areas such as the medical testing, you want to test the coronavirus vaccine, corona vaccine. In that case, you cannot say that I'm going to test with 90% of confidence, because it is very huge. If you give it to the 100 people, 10 people might die. That risk you cannot take. So in that case, many of the people will use 99% or more than 99% of the confidence level. Okay, so that is our confidence level. Based on that confidence level, we will calculate the significance level, which is like for 90% it is going to be 0.01. Here it is going 0. Sorry, 0.1, 0.05, 0.01. Okay, so this might not be visible, but you can. What is the third stage? Third stage is that select the test criteria. So which test are you going to select? If you are having in general people, if you know the variance of the population, you might go for the Z test. If you don't know the variance of the population, then you might go for the T test. Yeah, if you want to select some like guessing the distribution, you might use the chi-square test, or you might can also have the F test, which is two-tailed and one-tailed. Okay, so we will see in details this test later. So we will select the test. Each test will have the criteria, like here Z test will have the Z value we will calculate, T test will have T value we will calculate, chi-square that we will have some statistics, x square, this is sorry, chi-square we will calculate. In F test there is another one. So we will calculate this test statistics using the formulas, and based on this test criterion, we will select that, we will take the decision whether we want to accept the hypothesis or we want to reject the hypothesis. Is it clear so far? Any doubts?
Yeah, I didn't get the concept of null and alternate hypothesis. Means,
Okay, so
definition
hypothesis, you
was,
got the idea of hypothesis.
yeah, yeah.
What is the age of India? Average age of India. What is your guess? What is the average age of India?
38.
So 38, if you are saying, that is your null hypothesis. Okay.
Why?
So null hypothesis is something which we are assuming about our population parameters. Got your point?
Okay.
So you can do it
Okay.
alternate also. You can say that my null hypothesis is that uh, India's population is not 38. It can be other than that, but or less than 38. Okay. So basically, the thing which you want to prove, that you will select as a null hypothesis in many cases.
Okay.
Okay. What is alternate hypothesis? In that case, if that is not happening, because see, every time you cannot be correct while guessing, right? So I'm guessing that it is 38, but I cannot be correct in every time. So what is the alternate cases? It can be. So it is not going to be equal to the 38, or you can say that if you want to design, you can say that it is more than 38. Okay, or you can say that it
Okay.
is less
Okay.
than 30. So see, null hypothesis is something about the intent of the researcher. In many cases, like I want to I want to prove that the at max the rate of milk is going to be 52. In that case, I might do the null hypothesis that the milk rate in the India is less than or equal to 50. Okay. So what is your alternate hypothesis in that case?
Not equal to that rate.
No, it is greater than 52. So if it is not equal to 52, that means it will involve that it is 50 also. But your null hypothesis is saying that it is 52 or less than that, less than or equal to 52. Okay.
Yes. Yes. Thank you.
So in that case, your alternate hypothesis is going to be it is greater than 52. Got my point?
Yes.
Okay. Anything else in within these steps?
I think we are going to see it in detailed way when we will use Z test, T test.
Yes, yes. I'm just saying about these steps. So this is high level
Yes.
overview of what we are going to do about this. So this will be steps we are going to follow. Okay. So this is just high level overview.
जी, then clear.
Okay. So now see, when you are doing these decisions, right? So there might be the cases. Okay. So what are those cases? Suppose we accepted the null hypothesis. Okay. Or we may reject the null hypothesis. Correct. These two cases we will do. So in that case, there are some situations. Suppose that null hypothesis is true. Null hypothesis is true. In that case, I have accepted the null hypothesis. So this action, this block is correct because my null hypothesis is true. So in reality, the population of India is 34 in reality. Okay. And my null hypothesis is that the my mu is equal to 34. This is was my null hypothesis. I did my all tests and I accepted the null hypothesis. Really, it was 34. I accepted the null hypothesis. It is correct. But in reality, then my mean of age of India is 38, suppose. And my null hypothesis is that the age of India is 34. And I accepted the null hypothesis. Okay. Sorry. Sorry. Just
Rejected.
sorry. So actually, the mean is 34. Age of India is 34. But I rejected the null hypothesis. I said that my null hypothesis was actually correct. That it is 34. My guess was actually correct. But with some statistical methods, the problem of food. Okay. So null hypothesis, I rejected that the mean is 34. I rejected. So in that case, I will do the my type 1 error. Okay. What is type 1 error? Rejecting null when it is true. Got my point? And alternatively, the your type 2 error is that when the alternate hypothesis is true, but we accept the null. So in that case, my alternate hypothesis, suppose in this case, my mu is 38. And then also I accepted my hypothesis, which is mu is 34. Okay. So actually, in reality is 38. But I said that yes, it is correct that the average age of India is 34. In that case, I'm making the type 2 error. Okay. So it's said as alpha and this is the beta. Okay. So there is just names for these two errors, alpha error and beta error. Okay. Are you clear about this? This sometimes this will confuse you a bit. Okay. So in general, we want to minimize these errors. What is our aim? We want to minimize this error. So when the null hypothesis is actually true, I should accept it. And when there is alternate hypothesis is true, I should reject the null hypothesis. Okay. So this is what's intended. This is just jargon. This is will you will visit many a times. You will see this part. Okay. Okay. So now we will have the tails of a test. Okay. Now you have seen that why I have just drawn the normal curve and I have not drawn the any other distribution. Can you guess why I have not drawn the any other distribution? I have just drawn the normal curve. Why I have not drawn the curve which is like this, which is the logarithmic or geometrical, or why I have not drawn the curve which is like this? which is the uniform. Why I have
Uh,
only drawn the only
maybe
one curve? Hmm?
maybe we are going to see measurements.
Okay. So for that, we will go to our earlier slide. So what is this? The hypothesis is going to relate it to the population parameter, which is mean, standard deviation, variance. What we have seen from central limit theorem, that the mean of the sample mean
Samples,
follows the normal distribution. So
normal
many a
Normal
times,
distribution.
distribution.
yes. So many a times when you are going to take about the any from any distribution, if you are going to take the samples more than 30, so in that case it is going to start follow the normal distribution, the sample mean. So you need not worry about from which distribution I have drawn the sample, right? Got my point? And that's why we have drawn only normal, because once we know that it is more than 30, we will start assuming that the mean of our the samples is going to follow the normal distribution, and we are only looking at the mean. So what we are saying, that mean is equal to x or mean is not equal to x. So we are only talking about the parameters. We are not talking about the individual observations, right? That's why I have drawn only normal curve. Okay. What to do when our sample size is less, other distributions? In that critical cases, we will see it later. We will, in general, what we are going to use, that we will see the first. Okay. So now you will see. So our null hypothesis is that mu is equal to x. X can be any value. And my alternative hypothesis is that mu is not going to be x. Okay. So in that case, how we are going to formulate? So for which area we are going to select our null hypothesis? For which area in this our curve we are going to reject the null hypothesis? Okay. With 95% of the confidence, we have seen that how we are estimating the interval estimation. Suppose this is going to be my x with our confidence interval. So these two tails, this area, we will say that, see, because we are saying that x is not mu is not equal to x. In that case, we need to say that our mu is less than x, mu is greater than x. Okay. So the probability of x falling in the range will depend on our, which we have seen the estimation part, margin of error. If we calculate based on our significance level, we will decide this tails. Last time we have seen, what is this? This is alpha divided by 2, right? So if my significance level is 0.05, what is my going to be alpha? 0.025. Okay. So for this 0.025, I will calculate my z-scores, right? And that area I will select as my area of rejection. Correct?
हाँ जी.
But in case that mu is greater than x, so I will give you the hint. If you don't remember that which side of tail we are going to test, you see this arrow. Suppose this arrow is greater than. In that case, this is your rejection area. Okay. In the case of this less than x, my alternate hypothesis is that my mean is less than x. In that case, I can say this is my rejection area. So I will just say this is my less than, this is my greater than. Okay, this is just for your understanding. Okay, we'll just review it later also. Okay, is that clear?
Yes, Hanji.
Huh?
Hanji, we are clear.
Okay. So now we will first see Z test. Okay. So for the Z test, we will need to first check about this our Z score. So last time also we have seen the Z. What will be change? Okay, I'm not able to change my color. Maybe I will do it later. So what we have seen about the Z score, how to calculate the Z score for each observation. This is the formula which we have seen. It is the observation minus the mean divided by the sigma, which is my standard deviation. What? Are you remembering the Z scores? Hello?
Bhaiya, what are you asking? Dead?
Z score. I hope that you all are in flow.
Yeah, we are listening, but not able to remember that square.
What is the Z score? I will just I will try to remember you all again. Z score is that how many standard deviation my value is there from the mean. Okay, suppose there is one value here. This is my normal curve. Suppose this is my values about the height, so or age, and it is ranging from 0 to 100. So for my 0, what is the probability of 0? This is my probability of 0. This is my probability of maybe 20. This is maybe 40. This is maybe 50. Okay. So all the values are residing here. So probability of here 20 is residing here. So this is about the this value 20. So from my population, sample mean, which is x bar, which is residing here, how many standard deviation it is away. How I can calculate? What is my observation? Suppose my age is 20, my mu is 50, my standard deviation is 10. In that case, how many standard deviation it is away? 20 minus 50, it is minus 3. 100, minus 30 divided by 10, which is equal to be minus 3. So minus 3 standard deviation here, it is going to be reside my 20 value. If the standard deviation is 10 and mean is 50. If I change the mean, suppose I take the mean is equal to 30, then 20 is going to reside is only minus 10 divided by 10 is equal to minus 1. So only one standard deviation, maybe like this. Here my value 20 is going to reside. So this is what my Z score. So probability that my 97.3% of values will follow within within 3 standard deviation, my 99.73 values will fall within the 3 standard deviation of the my mean. You got my point? Are you clear
Hanji.
about the Z score? Saro, are you clear about Z score? Vijay?
Yeah,
Yes. Actually, one doubt is when you are telling no, this normal distribution, if it is a positively skewed or negatively skewed, will that be affecting the Z score? Z score?
No, it will not affect the G score because what will happen?
Hmm.
This is
Okay.
about the standard normal distribution. What is standard normal distribution? Where mean is equal to 0 and standard deviation is equal to 1. Okay.
Okay.
In reality, this will not happen.
Okay.
But what we are assuming that this is the standard normal distribution.
Hmm.
Okay. In that case,
Okay. Got
what
it.
we can do, we can tweak our data. Okay. And we can change the mean of our data to 0.
Hmm.
If you change the standard deviation, if you increase or decrease, last time, if you remember, you were, I think, not there. We have plotted this in Desmos. Okay. You can
Okay.
search on the internet.
That's was I.
Yes. So
Hmm.
Desmos, again, then you search Desmos normal distribution. So if you
Hmm.
change the uh, standard deviation, the spread will change. So suppose if you so the your normal distribution might look like this. Okay. So now it is same
Okay.
color. That's why. So the spread will increase or decrease. Okay. Height will
Okay. Okay.
increase or decrease. Okay. Except that nothing will happen. This spread, this standard deviation is more than your three standard deviation will also increase because your standard deviation goes up from 10 to 15. Okay. In this case, 1 to 2 means 10 to 20. Your three standard deviation distance will also grow from 30 to 60. So
So
mu
which means the data will be so dispersed.
dispersed. So
Ah,
range,
yes.
your range. So what we will say, the
Ah.
range of your data will be very high. That's what it
Hmm.
means. So it is very scattered data. So that doesn't matter much. Okay, is it clear?
Okay.
So based on this Z scores, we can calculate the p value also. Yes, based on this p value. Suppose this is going to be 95.45%. Okay, so means my all data up to 95.45% is going to reside with this. So remaining 0.25 is going to here. Remaining 0.25 is going to be here. This is what I was saying when there is tails of the this tails we are saying na? So we are going to reject this data. This data is coming here that we are going to reject. So that we will for our value of z we will select z. Suppose we selected 2. Okay. So 95.45% times our data will follow in this curve. So if z value, if I calculate for certain mean which is greater than 2, suppose it came 3, that means where my mean is falling, mean is falling on this side here. Okay, I'm not able to change the color, otherwise I would have. So I will reject that null hypothesis. Okay, this is what I was
Okay.
just imagining. So z test we will do the same. This is the one sample z test formula. Okay, what is very simple. So now they have just converted this formula. If you check here, z is equal to our observation minus mu divided by sigma. This is for our sample. Now this is about our mean number of samples we have collected, and we are checking the distribution of the sample mean. We are not only checking about distribution of observation. Observation, we have taken one set of samples, and now we are moving to the number of such samples I am taking from the my population. I am drawing my uh, like 30 set of 30. I have drawn 10 samples or 20 samples, and now I am dealing about that. So in that case, my sample mean. So I am checking sample mean. This is mu zero is my hypothesis mean. This is my hypothesis. Okay. This is what I have observation. I have collected the sample. I have calculated the mean of that sample, which is going to be x bar, and I have assumed this is my hypothesis, my null hypothesis H0 is that mu 0 is equal to 34 in case of average age of India. Okay, and I have calculated my x bar which is 28. This is what example we have taken earlier. That's why I'm just repeating so that you will understand the context. Here again I will just see here one thing for the Z test is assume that you know the population standard deviation. So this is not the mu x bar, sigma x bar. Sigma x bar is the population standard deviation. Sigma is about the population. So here it has been assumed that you know the population standard deviation and you will divide it by the by under square root of number of your observations. And if you check this is the formula of our standard error. This is the formula for standard error which has been resubstituted in our one sample z-test formula. Okay. Then for some significance level, okay, it has been calculated the type of tests and the critical values. So now these critical values are about Z. Okay. What is this significance level? 0.01 means 99% of confidence. Okay. Now this is two-tailed. Two-tailed. So now you will take example of this 0.05 because we have some data. So now here we have seen that within two standard deviation, 95.45% of the data will reside. Okay, we will just verify this up to two standard deviation. So what is Z score at this level? Here it is going to be -2, it is going to be +2, right? Now we will just verify it within our two-tail sample test, which is we are saying that mu is not equal to sorry yes, mu is not equal to x. So now here you can check it is 1.960. Why it is 1.960? Because this is for here it is 90.5.45 and it is here only 95%. So for 95% data accuracy, you will have the standard deviation Z score of 1.96 plus minus. Okay. So if I calculate this Z statistics, so I plug the values. Now we will do it here very organically. Like Z is equal to my 28 because this is my population mean minus my hypothesis mean which is 34 divided by suppose I know the standard deviation which will assume it is 10. Okay, of the population it is 10 divided by how many samples you have selected. Suppose I have selected the 1000 samples. Okay, in this case suppose I will select only 100 samples. Okay, 100 samples, what you will get? 1 divided by 10 and here I will get 6 divided by 1 divided by 10 which is equal to 60. Okay, so 60 is very 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 high.
Mayur,
Yes,
is it under the square root of n or like 1000
yes,
or 100?
square root of
Huh.
n. So okay, so this will come the 10, so it will become the 1, so it will become the 6,
6.
right? This
Yeah, yeah.
sorry, I just not seen that underscore. Okay, so my Z score will become the 6 with my significance level of 0.05. What is my critical value? It is plus minus 1.96, but here I am getting it is 6, right? So it is far more greater than our significance level or our critical value. That's why we will not be able to accept the null hypothesis and we will reject the null hypothesis that our mean is 34. Got my point?
Bhaiya, after 6, can you repeat? After finding the value 6.
What after finding the
Value 6. Z is equal to 6.
yes sir. After finding the value 6, I will check the critical value. So now this you can calculate using the Excel. Last time I have shown you, or maybe in the next session I will again show you that how to calculate this for any significance level. Here they have taken the standard one. This is what standard you will take, 99%, or this is about the 95%. But we can have the significance level for 0.1, which is about 90%. Okay, I will show you that later. For that also you can calculate the Z score, your value. Critical value will reduce, so it will come again to the one, or maybe so for this one to take almost 90% of data. You can see that this is 68% of data, this is 95% of data. So somewhere around here it will come. So it might come around 1 point, maybe 5 or 4. So this is what, but I will tell you using the Excel. That is not the part. Once you know the critical value for your confidence level which you have selected, you will get the this Z value, right?
हाँ जी.
Until you are clear? Once you get
Yes,
this
yes.
Z value, you will compare with your calculated test statistics. It is called as the test statistic Z. So for Z test, we are having the test statistics Z that we have calculated using the formula x bar by mu, that is formula. It has came the 6, but our critical value was 1.960. Okay.
Yes.
As it is greater than that, we will reject the null hypothesis, and we will say that we are accepting the alternate hypothesis, which is not equal to mu 0 is not equal to 34. Okay.
हाँ जी. Okay.
Until here clear, everyone? Any doubt in today's session?
Mayur,
Ah,
we are getting one thing I'm not able to clarify. We are getting 6, no?
yes.
The critical value it is mentioning at 1.9. So we are rejecting this null hypothesis. Is that correct?
See, what I will tell you first thing. Uh, for each test, it will change. Okay. If it is greater, some tests will say if it is greater than this, then only we will accept test
Okay.
statistic. If it is somewhere, it will say if it is less than this, then only we will accept. Okay. So while you are designing your null hypothesis, okay, like I have said that here, it's not equal to, or it is less than, or it is greater than. Okay. So this is
Okay.
one tail or two tail. These all things you need to check. Okay.
Mhm.
While
Okay. Okay.
taking the decision about the test statistics, like for chi-square tests, if it is the test statistics is greater than your critical value, then only we will accept the null hypothesis. Otherwise, we will reject. Okay. So
Okay.
every time when you are doing, no need to remember. Everything data is available on the internet. You can go and search. If it is available, you can just check that whether I need to accept or reject the null hypothesis, because it is very
Okay. So
confusing part.
okay. Well, actually, it's about the designing part, like where
Okay.
how we want it. If it is getting means we will accept it. Otherwise, we will reject it. Is that
Yes,
right?
and the second part is that which test you are selecting, whether it is T test, Z test, F test, or chi-square test, or any other test. For
Okay.
that test, you need to check what we need to do with test statistics.
Okay. Each
There
test
is
having their own design as well, like this.
what?
Each test will be having their own design, like.
Yes, yes.
Uh,
So there will be guide for selecting the null hypothesis. There will be standard null hypothesis also will be given to you.
okay.
Uh, yes. Priya, you are saying something?
Bhaiya, what is critical value? What is the concept behind critical value?
Critical value is that, see, when you will buy the iPhone, at what price you will buy the iPhone? Suppose I'm not saying I'm having the iPhone, brand new iPhone. Priya wants the iPhone. At what price you will buy the iPhone? I'm asking you. I'm not saying that I will sell at this price. I'm asking you how much you can pay for an iPhone. I'm having iPhone 15 Pro. How much will you pay?
1 lakh around.
Yes. So as per your financial condition, you have said that you will pay 1 lakh. This is your critical value. So what you will say, if you are going to sell me less than or equal to 1 lakh, I will purchase the iPhone. If you are going to sell more than 1 lakh rupees, now currently I think iPhone 15 Pro is 1.5 lakh. I will not purchase the iPhone 15 Pro, right? So this becomes your critical value for selecting or rejecting the null hypothesis. Null hypothesis is something assumption you have. So you are having the assumption that the India's population will be the population average age of population is 34. So at what point you will reject or accept that hypothesis with certain confidence level? Okay, are you clear?
Yes, yes.
So this critical value you are deciding. First importantly, you said that. Okay, so you will say how I am deciding, because you are deciding the level of significance. See, for the time pass I am doing the research. Okay, that time I can select that my significance level is 10% only. Okay, for 10%, what will be my alpha? Where I put for my 10% significance, my confidence level is 10%. My significance, how much significance level will be? So it is going to be 0.9. Okay, 0.9. That means for that means only 1% of value I'm going to, sorry, 10% of values I'm going to exclude. Other 90% of the values, I don't worry. 90% if I'm wrong, then also I'm okay. Only 10% I am right. For that you will design and you will find out. So for this 0.09, I will tell you the Excel formula. You will can calculate the critical value as well. Okay. So this test you can select on your own. Any other doubt?
Yeah, this significance level and confidence level both are same.
No. See, confidence level we are saying in percentage, correct?
Yeah.
95%, 99%. Based on that, you will
Mhm.
scale it the significance level to the what is the our formula for significance level? 100 minus confidence, okay, divided by 100. Suppose my confidence level is 90, so how you will get 100 minus 90 divided by 100? This is going to be 10 divided by 100. This is going to be 0.1. Okay, that's why for
Okay.
99%, how it is going to be 100 minus 99 divided by 100, which is equal to 1 divided by 100, which is equal to 0.01, which is here. This is for 99% of confidence level. This is for 95%. Anything else?
No.
Okay. So what I will suggest you, just go through our this business statistics guidebook. See, many a times what we are not focusing this technical part, but what is more critical, this part. That's why this is our logo of the group. Okay, because once you understand this part, you on your own can select the level of significance. You can select that when I'm going to reject hypothesis, when we are going to accept the null hypothesis. So there are, I just forgot to tell you the one thing, and that is here I will tell you. There are two types of doing the hypothesis test. The first one is that test statistics, which we have did now, correct? Right? And another one is that p-value. What is this p-value? Probability. So this test statistics is one method. Now we have calculated the z, correct? Right? We have not calculated the p-value. What is just p-value here? You can convert that into p, correct? This 1.96 you can convert into the p-value, how much p-value I will get, and that sort of things you can do with Excel formulas. Last time we have did it, if you remember. So second thing is that we will do it p-value. So two methods are there. We can choose any one of them. Both are somewhat similar. Just two different approaches are there. So based on p-value, like there will be significance value of 0.5. So if my p-value is 0.05, so if it is less than 0.05, that means the probability of observing the null hypothesis is less than 0.05. I will reject the null hypothesis. Okay. So like this, there are two approaches. Next session we will try to see that also. Oh, so with that we will stop. Any question?
No, here.
Okay. So with that we
Not
will.
Bhaiya.
Huh? Okay. So with that, we will stop today. I hope that today's session is also recorded. So I will share you the recording link also. Please watch it and also try to see some material on the hypothesis testing. And keep in mind that we need to do the practically. We are going to do this for our own data. Okay. Now we have not checked in Excel, but next time we will do see that how we can do this in a Excel also. It's not a difficult part. Once you know the formula, you can just convert it into the Excel formula. Okay. So for now, thank you so much, and we will meet in the next week. Thank you so much. Bye.